Okay, so right now we'll do movement. So your previous one, if you're, let's say you use blue to represent the coefficient, is a reflection on the x-axis, then you don't use that color. Now you use a different highlighter color, okay? So I'm gonna do a recap. Okay guys, so right now I'm going to do y is equal to x. Now y is equal to x. Do you notice that x, what is the power? The power is a 1. So what is the parent graph? Because now the one in black is the parent graph, right? So these are the different movements. This one you all need to memorize. This is my parent graph. Correct now, guys? So what happens is that right now I have, if I add a negative in front, okay? Let me rewrite it. So this is the y is equal to x. So right now, if I add a negative in front, it means that is y is equal to negative x, right? So remember when I teach you, in front is a negative, right? When a coefficient is a negative, what does that mean already? If the in front, the coefficient is a negative. It's a what? No, you need to use proper terminology. No, you need to use the proper terminology. Look at your notes. Tell me what's the proper terminology that you have to use. Yes, it's a reflection. Reflection on the what? Yes, you all need to use all this proper terminology. So when a reflection means, can you see this part here? I'm going to do this part first. When it's a reflection, it becomes here, right? Then for this part, when it's a reflection, it becomes here. Correct or not, guys? So therefore, when I reflect, it becomes like this. This is a reflection. Now we're going to change color. We're going to do this called the movement. So can you see now is my original y is equal to x. I'm back to the parent graph again, the one in black, right? But I have a plus c. Plus c means it's a constant. So plus c means this is a movement up or down. Movement up. Means I move the graph up by c, whatever c value. So right now, can you see it's almost parallel, right? And this point here is c. You all got it? So that is the purple one. Then there is another scenario where is y is equal to x minus c. What does minus c means? Here, it's still a movement, but it's a movement where? Down. So it's the same parent graph, the one in black, but here is minus c. You all got it? So you all can flip behind. I believe behind is blank, right? Is it behind is blank? You all can write all this down now in 4 different colors. So just now we have x to the power of 1. Now what's the next one I'm going to do?
Wow.
Yeah, x to the power of 2. So I'm going to do y is equal to x to the power of 2. Now these two are very familiar with for you guys, right? Y equal to x and y equal to x squared. Because this one you all have learned in lower set already. So make sure that it touches the origin. When I say origin, is the black dot there, the 0, 0 mark. That is the origin. So just now what we learned, the one in pink, the same thing. When y is equal to, the parent graph is y squared, right? So add a negative in front, it'll become a negative x squared, right now? So add a negative x squared, what happens now? It'll be a reflection on the x-axis. Very good. Now let's do the purple one. Now the purple one is y is equal to x squared plus 2, for example. Yeah. So what happens if it's x squared plus 2? It's a movement up. So it will be the same. It will be a movement up. And now this mark here will be how much? 2. Now what about this? If let's say I have y is equal to negative x squared plus 2, what does that mean? Movement up also, because it's plus 2 plus 2. So it's a movement up. Okay, you know, this to be a nice set face. And here will be how much? 2. Got it? So next, let's do the one in blue. So the one in blue is y is equal to x squared minus 2. Minus 2. Can you see the parent graph right now? I have the same parent graph, but I minus 2. What does that mean? So you take the same parent graph, means the one in black, and you have to bring down by how much? 2. So what is that mark there now? Negative 2. So what about this one now? So it will be bring down from the pink one, right? So bring down from the pink one means right now here is, wait, it needs to be like parallel. So here is negative 2. So this is y is equal to minus x squared minus 2. That's it. So one parent graph of just y equal to x squared, you have 6 variations. So can you see, as long as you understand the concept, that was what I was trying to say, you memorize just the parent graph, the one in black, and you understand how different variations happen, you will never ever be confused or get wrong. Okay? Okay. So right now we'll move on to y is equal to x cubed. So x cubed is an S-shaped graph, correct now? So S-shaped graph means we have a half. Can you see? The half set face first, followed by a half smiley face. So this is y is equal to x cubed. Next, we'll do the parent, this is the parent graph. So when now the coefficient is a negative, what does that mean already? So instead of half, start with a half set face, it will become a half smiley face, followed by a, so this one must be more curved. Then after followed by a half set face. Okay, so we are done with pink already. Now let's do purple. So purple says that if it's x cubed, I here have a plus 2. Here's a plus 2 means what? Movement up means I move the whole graph up by 2. Okay, so I move it up by 2, like that. So this will be how much? 2. So right now here I have y is equal to minus x cubed plus 2. What does that mean? Means I take the pink one and move up by 2, right? So here will be 2. So that is the pink one. Next, let's do the blue one. We have y is equal to x cubed minus 2 and y is equal to minus x cubed minus 2. That means that right now I move the graph down by 2. So here will be 2, minus 2. And then here will be also minus 2. The shape will be like that. Finish, done. All right, so the next one we're going to do is y is equal to x to the power of minus 1. So for this one, the parent graph, it is, remember guys, so can you see as close as possible? Then become like that, then as close as possible. Like almost touching the x-axis, but it's not, okay? Then here also same thing, can you see as close as possible? And here must be as close as possible, right? So if you're not too good, you can draw the tiny lines first, then you can do the curve like that. Got it, guys? And make sure that it must be symmetrical. Okay, guys, so next we'll move on. Can you see the one in pink is a little bit intimidating because you have 2 negative, correct now, guys? So can you see that this one is actually not scary, because if you do the one in black, the parent graph, where is x is equal to minus 1, the one in pink is just negative in front, correct now, guys? So what does that mean, the one in pink? Means we'll take this person and do a what? Reflection on the x-axis. So can you see now the one being reflected is here and here? So can you see how I do it? I draw the 2 tiny lines first, then I go and do this mark. It'll be a lot easier and nicer. Then also the same thing for this person. I'll do a reflection. I draw my 2 tiny lines first, and then I go and do a curve like that. So it will look very nice. Okay, so guys, right now, pens down, listen first. We're going to do the movement already. I'm going to do the one in purple. So the one in purple says that what? I have y is equal to x to the power minus 1 plus 2, right? Now you have to be very careful here when it's a plus 2. Because what's so special about this one that I mentioned to you all before? It has what? This kind of graph. It has what? It has? Look at the notes. What's so special about the power minus 1? They have something. Asymptote. Yes, very good. They have an asymptote. So what happens when I do a plus 2? It means that my asymptote now goes up by 2 also. So right now my asymptote will be dotted line like that. Whereby it's y is equal to, this is not y equal to 2. Yeah, y equal to 2, right? But it's asymptote means now my graph will be like that. And like this. Can you see that now? This is my graph. So if your graph you draw like that, but you never go and draw your asymptote, what you're going to do, your teacher might is wrong. Because this is a special graph. It has asymptote. So guys, for this case, I will not do blue. Blue, you all know will move down, right? So I do the -2 for the pink one. So it will not look too messy. Yeah? So let's do the pink one right now. Whereby this is the blue one. Minus x squared minus 1 minus 2, right? So it's the same as the pink one, but just that now it will be a movement downwards by 2. It means that my asymptote will also move down by 2 right now. So I have y is equal to minus 2 here. So what happens to this graph? This graph will be here to here and here to here. Can you see that? So that is the blue one now. Okay, that's all. Okay, so the last one is, I think you all can predict by now already. What is it? Oh, thank you for having the switching off the lights. Okay, so right now, pretty simple. You all know already. I'm going to do the parent graph of y is equal to x to a power of -2. So how to do this one? X to the power -2. Can you see I draw the tiny line here? Draw the tiny line here first. Then I connect. It'll be a lot simpler, right? Let's make sure it's almost parallel like that. Then here draw a tiny line, here draw a tiny line. Then after that I connect. Like that. Oh, but it doesn't look very symmetrical. Nope. I need to make it as symmetrical as possible. Yeah, this is the closest. Okay, I still don't like it. It's not nice. Let me do the one on the left first. Symmetrical. Now it looks better. Okay, got it? So this is y is equal to the power of -2. So because of this, right, I can form the next one. Can you see it's the same? Y is equal to x to the power of -2, but now I add a negative in front. So there's nothing scary about 2 negative. As long as you memorize your power graph correctly, the parent one, everything will fall into place. Yeah. So it's negative means very simple. It's just a reflection. Not nice. So almost parallel and almost parallel. Okay, got it. See, beautiful. Nice. All right. So right now, remember there's an asymptote for this person, right? So if I'm going to do, wait, the movement up is blue, right? No, purple. So right now I have y is equal to x to the power -2 plus 2. That means that I'm going to move the graph up by 2. And then this one has an asymptote. So right now, remember my original asymptote is here. My original asymptote means is here, right? Correct. Can you see? So draw slightly above. I know that my original asymptote is y is equal to 0. So right now, if I move up by 2, it means that my asymptote will now be at y is equal to 2, and then it will be the same shape here and here. Got it, guys? That's it. So same thing for the one in pink. Right now, I'll do y is equal to minus x to the power of -2 minus 2. It's like, holy cow, so many negative. It's nothing scary if you understand the whole concept, right? So right now, my original asymptote is at what? Here, right? Can you see here? So this is my original asymptote of how much? Y is equal to 0. And then now I'll just bring it down by 2. So it'll be here, right? And what's the line? It's y is equal to -2. So draw it, look something like that. And then draw it, look something like that. Okay, that's it, done. Now, for this graph, the parent graph, remember I told you that in your notes, the parent graph is not y is equal to 2x, correct? In the notes, I asked you all to change. What's the parent graph? Y is equal to a times b to the power of x. Now, this is super important. You all need to be very careful right now. So, first thing first is the requirement is that this person has to be positive x. I repeat, this person has to be positive x, okay? It needs to be positive. So sometimes the teacher is very tricky. Later, I'll tell you a scenario where your teacher will give you y is equal to 1 over 2 to the power x. And this is when you have to be very careful. Your indices must come in. Your indices is a part that you all need to take note of. So later I'll teach you the one on the blue one. But first, let's go on to the concept first. The concept says that why we need to make it in the format. So this is the format of a times something to the power of x, right? A is one term on its own. So this a talks about the y-intercept. Okay, so we have the parent graph where it's like that, right, guys? Correct or not, guys? Wait, I better draw in one color because later it will be very complex. So what happens? Because it's the y-intercept means that this person will be my who? Very good, A. Got it so far? Who is confused? Now, next. This one, pay attention, everybody. If you are very sleepy, you have to wake up already because this one, if you missed it, means the end. Now, this one has two scenarios. The first scenario is where B is what? Does anybody know? Okay, close. But B must be greater than 1. The value of your B means the base of something to power x. That something has to be greater than 1. When it's a greater than 1, it's something drop. Something drop. When it's greater than 1, it is actually a growth graph. So it means that the shape will be like that, going upwards, like airplane, fly upwards. Now, the second scenario is where my B is greater than 0, but it's smaller than 1. Got it? There's no way your B can be equal to 0. There is no way your B can be equal to 1. That's why they have this range. 0 to 1. Now, 0 to 1 means right now, your B will be a decay graph. Means it's like the airplane landing already. Ew. Okay? So I'm going to highlight. These are both parent graphs. You need to remember. Okay, I better don't confuse us later. Some student will get confused. So this is the airplane landing. So here is still A. But for this case, it's a very long story. This is a graph of y is equal to a bx, comma, where b is what? B is more than 1. Very good. So this is same thing also, where y is equal to a bx also. But the condition is where? Yes, this is it. So later I'm going to teach you the more variations. Right now, you all can write this whole idea first. So right now we'll do the 3 toughest question that a lot of students cannot do. Okay, the first toughest question is that y is equal to -2 to the power of x. The next toughest question is y is equal to 2 to the power of -x. And the third question is 1, 2, and 3. Y is equal to 2x. Or rather, y is equal to 3x. 3x can? Yeah, 3x can. Okay, Then I do the fourth one, the easy one, because once you have mastered 1, 2, and 3, you should definitely be able to do this. The fourth one, because the fourth one is the easiest. Okay, so now, based on these four, or rather the three most toughest question, is that first, the first question is this one. So why would students have a lot of difficulty? Because they don't follow the golden rule. The golden rule in doing this is, can you notice that the power are all in terms of x? The moment I know the power is in terms of x, is the last variation really. Why? Because all those when we do you notice that the power is never an unknown? The power is either 1, 2, 3, or -1, -2, -3. Right now, guys? It's never ever an unknown, right? So right now, the power is unknown means I know for sure is the last one. And the last one clearly states that my y must be in terms of a times b to the power of x. Right now, guys? Correct? So I'm going to do number 3 first. Okay? Number 3. First thing first is, it's not in the right format because it has to be in this format. So not just in this format. Do you remember just now, guys? I told you that the x must be positive. The first condition. And then the next condition, you need to know your b. Whether your b, is it greater than 1? If b is greater than 1, mean it is a growth graph. If b is between 0 and 1, that means that it is a decay graph. Got it? So let's look at number 3 first. Number 3, what is the format? If I do the format for number 3, does anybody know? Y is equal to a times b to the power of something. Awesome. So what does that mean? This means that this is your y-intercept. Next, this means what? Yes, growth. So with that, I can start drawing already, right? So that means that I can know that my y-intercept is at 1 and know it's a growth graph, right? That's it. So this is my y is equal to 3 to the power of x. Finish. Then don't forget to label 1. That's all. Now, some teachers are very particular. They will want you to put your asymptote. So you got to listen in class whether your teacher wants your asymptote, yeah? Next, I'm going to move on. It's number 1, okay? So let's do number 1. So for number 1 right now, I need to make it in the form of y is equal to something times something. So anybody know what is it now?
1 times.
What?
1 times negative.
Yes, -1 times 2 to the power x. Now guys, take note, y equal to negative. This -2 to the power x is not the same as -2 to the power x. They are not the same, okay? Please be very careful with your algebra. Now, next thing is a lot of students thought that this -1 means the y-intercept is -1. Yes, you are kind of right. But this is a special case where it's written like that. -1 times 2 to the power of x. Got it? Okay, so what does that mean? It means that first, I have to draw this person first. So let's draw this person. This person is at what? Okay, why I say that this person is wrong? Because, right, if you don't modify to the second part, if let's say you just draw this, you know what you think it is? You think that number 1, your y-intercept is -1, right? Number 2, you think it's a what? Growth or decay? Growth. Then you think that your answer is like this. Okay? But actually it's wrong. Got it? So what is the right way? The right way is, first thing first is draw. This is y-intercept first, right? And then it's a growth graph, correct or not? Who doesn't understand? Because this is, the y-intercept is 1. Then can you see here is 2? 2 means it's this condition, right or not? But it's greater, so it's a growth, right or not? But now we have this negative here. So what is this negative means? Very good. It's a reflection. So now instead of 1, it will be -1, and then it's a reflection. So this is the answer. Y is equal to negative to the power x. 4, you must make sure that you must write it as y is equal to minus, open bracket, 3 times 5 to the power x, close bracket. Sorry, it must be a round bracket. So we must do the 1 inside first. If we do the 1 inside first, what does it mean? My y-intercept is how much? 3, and it's a what kind of graph? Growth or decay? Growth graph, right? Then right now, because the in front is a negative, so I cannot draw like that anymore, right? It will be a it will be a reflection, right? So reflection, pay attention, this is super important. So can you see that here is almost parallel? Go all the way down. That is the right way. And here it's -3. Then how to draw the asymptote? Look carefully how I draw. Can you see? Even though it's the same color. Can you see? I draw just nice touching, but yet can still see my dotted line. Can you see that? How I draw like that? Y equal to 0. And that's the end for number 4. So number 4 is very simple. Number 4 is same as number 1. Okay, it's the same type. Now the last one is we'll go on to do number 2. Now number 2, I would say is the most difficult question. Why is the most difficult question? Because you need to be very good with your indices. If you're not good with your indices, number 2, you can just say bye-bye already. Yeah. So how to do number 2? So first thing first is we need to make it in the form of y is equal to something, right? You must write it in the right format, correct or not? But the format says that my power must be positive. But you look at number 2, does it fulfill what the format wants? Does it fulfill? Doesn't fulfill, right? So how are we going to make the power positive? What would it be? Y is equal to 1 over 2. Okay, so first thing first is I want you to know that this is actually like that. You all should know by now, right? Power times power. So if you do not know how to go from this to this, you might need to revise your indices. Okay, because by now you all should know it's like that. And then remember, 2 to the power of -1 is actually how much? 1 over 2. And the whole thing to the power of x. Okay? So some students, they say, Miss Lin, can I do this way instead? Means this one, I put it like that. Can, but you face a big problem because it doesn't look like the one in the black format. Then you have to rewrite into like that. Because this is x, right? You must know that this is actually the same as this. Because why? 1 to the power of 2 is 1 to the power of anything is always what? Okay, if you don't believe, use your calculator. 1 to the power of 2 gives you how much? 1 to the power of 2, huh? Then what about 1 to the power of 3? 1 to the power of 10?
1.
So 1 to the power of x?
1.
Yes, and these two is the same. So your indices must be very strong. That's why, can you see I don't do the first method? I do the second method instead. You'll make my life a lot simpler because I need something to the power of x. But it still doesn't look like the format that I want. It should be y is equal to what?
1.
Bracket half to the power of x. Got it now? So what does that mean when I want to draw? First thing first is, do I know the y-intercept? The y-intercept is 1. So I know here is 1. What else? Decay graph, because this is a half, right? So it's a decay graph. It's going to be like that. Almost touching the x-axis, but not touching the x-axis, like almost parallel. That's it. That's all for number 2. So in case you're wondering, Miss Lin, my school teacher tests me this, something like that, but then got extra +3. Now, what does that mean already? When the behind got a +3. It's the same graph that I teach you all, right? But just that now I have to move it up by, when I move it up by 3, something also goes along. Yes, the asymptote, the dotted line will also move up by 3. Got it now? Yes, that's it.